Hydroelectric energy. Kinetic energy in the flowing water or the potential energy in the water reservoir is a conventional source of energy. In hydroelectric power plant, the potential energy in water stored in a dam is converted into kinetic energy of water. Fast flowing water is brought from the dam to the turbine at the bottom of the dam. The kinetic energy of the flowing water drives the turbine. The turbine in turn drives the generator to generate electricity. The block diagram showing different components of hydroelectric power plant is shown in the figure. So first we have water reservoir with potential energy. Then we have water turbine, then generator, and finally the electrical energy. So we have potential energy in water, then the kinetic energy in flowing water, kinetic energy in the turbine, and finally the electric energy. The schematic of hydroelectric power plant is shown in figure 5.17. Water from the middle of the total height of the dam is taken to the turbine as shown in point B in the diagram. So from here water flows. So what is significant about point A, B and C? If the gates are at point A, then you will get maximum kinetic energy. But once the water level goes down A, then the electricity production is stopped. If you select point C, then you will give least kinetic energy. So the optimum level is B, where you will get adequate kinetic energy and also for the maximum time. So point B is good for that. Then, since no fuel is burnt in hydroelectric plant, no air pollution due to combustion of the fuel results. However, considering the issues like forced migration of large community, submerging of forest and fertile land, adverse effect on living creatures of the river, it has always been a point of debate whether the hydroelectricity is environment friendly or not. Advantages of hydroelectric power generation: since no fuel is burnt in hydroelectric power generation, there is no pollution resulting from the combustion of fuels. If there is sufficient water storage in the dam, it is possible to generate electricity as and when necessary. Although water reservoir is used for power generation, it can be replenished during the rainy season, leading to uninterrupted power generation. The problem associated with hydroelectric power plant are the backwater due to storage of water in dam may submerge villages or towns in that area. This leads to the problems of rehabilitation of displaced people. Moreover, this can also submerge forest as well as the fertile land. Obstruction of the flow of river water may have adverse effect on the living world in the river. So, in the Tiheri, Uttarakhand, hydroelectric power capacity 2400 megawatt, Koyna, Maharashtra 1960 megawatt, Sri Shailam, Andhra Pradesh 1670 megawatt, then Nathpa Zakri in Himachal Pradesh 1500 megawatt. The kinetic energy in wind. So here the section changes and the new topic is wind energy. The kinetic energy of the wind has been used since long for lifting water or for driving the flour mills. Wind energy can also be used for electricity generation. The machine which converts kinetic energy of the wind into electric energy is called wind turbine. As the wind strikes the blades of the turbine, the blades rotate. The axle of the turbine is connected to electric generator through a gearbox. Now, what is the need of gearbox here? Because we know that the speed of the wind will not be adequate to generate enough frequency in the generator. We know that standard frequency of electricity in India is 50 Hertz. So, the frequency that we get from the wind turbine has to be increased for the generation of electricity at a fixed frequency, 50 Hertz. So the gearbox serves that purpose. It increases the frequency of rotation. The function of the gearbox is to increase the rotation per unit time. Thus, rotating blades drive the turbine, and the turbine in turn drives the generator, and then electricity is generated. Various stages in the wind energy generation system can be shown. So first we have a wind with required velocity, then wind turbine with large fins, generator and electric energy. This is and here you can see that schematic. There is the blades which rotate due to wind, then that kinetic energy transferred to shaft, gearbox, ultimately generator. So kinetic energy in the wind converted into kinetic energy of the turbine, ultimately generated into the electric energy. Wind turbines with capacity right from less than 1 kilowatt to about 7 megawatt, 7000 kilowatt are commercially available. Depending on wind velocity available at the site of installation, wind turbine with specific capacity is selected. The wind velocity at specific location depends on many geographical factors. Wind velocity is usually high on seashores, and that environment is appropriate for installation of wind turbines. Wind energy is a very clean energy source. So that is the advantage of wind energy. But disadvantage is that the wind velocity necessary for wind energy generation is not available everywhere. In that sense, use of wind energy is